today we are going to discuss 2015 final paper, question number 1, right? So the question I have already posted there, right? So I don't want to waste time on reading the question, right? So basically, in this question, part A, they are asking us to show that transmissibility ratio at steady state is given by that formula, right? So let's see how to obtain that, right? So now this is the system, right? So here we have a mass m, right? Or that is the machine mass, right? And there is an excitation force p sine omega t that is acting on the mass, right? This x is the displacement and this is ground, right? So now this mass is isolated from the ground by introducing a spring and a damper, right? So the displacement or the response of this machine due to this excitation force, right, is given by P divided by m omega n squared times 1 over square root 1 minus r squared whole thing squared plus 4 beta squared r squared times sine omega t minus 5, right? So what is this 5? This 5 is the phase angle of the displacement or the response, right? Because here if you see, we have the response or the displacement, right? Motion of this mass, right? So now here this 5 is actually the phase of this response with respect to the excitation force, right? Okay, so now we have to obtain the given formula for the transmissibility ratio, right? So let's start from the force that is transmitted to the ground, right, through the spring and the damper, right? So let's start Ft, right? So what is this Ft? Ft is the force that is transmitted to the ground, right? So that equals, right, if I sketch the free body diagram, right? So you know, here we have the mass m, right? The displacement or the response x is downwards, right? So that means this mass is pressing the spring downwards and as well as the damper. So due to that, the reaction on the mass will be along the upward direction, right? The reaction that is exerted on this mass from the spring is along the upward direction. It is kx, and for the damper it is cx dot, right? So you know that. So what is Ft? So that equals, right? So anyhow, that is the force that is transmitted to the ground, right? So it equals kx, right, plus cx dot, right? Okay, and x we already know, right? But here one substitution that we are doing, because the reason is like we can't write this every time, right? This 1 upon square root of this part, right? So we are going to introduce a special name for that, right? So let me tell you that. We can call it this 1 upon 1 minus r squared whole thing squared plus 4 beta squared r squared, right? We can call this as neta, right? So what is neta? This is what we call as dynamic magnification, right? Magnification, right? So we can use neta to represent this part, right? Okay. So kx is doesn't matter, you know that, k times. So now you can write this whole part, p divided by m omega n whole thing squared times neta, right? Sine omega t minus y. No worries, sine omega t minus y, right? Because you do not have to differentiate x, right? Because that is x. Then plus c times, now we have x dot, That means differentiate x with respect to time, right? First derivative, right? So how can you do that? You don't have to worry about p divided by m omega n squared because it is a constant, right? Plus p divided by m omega n squared, so that's a constant, and neta also, right? Here neta also you don't have to worry, right? So keep it neta, right? Then you have to differentiate this person, right? So what will be the answer if you differentiate this one? Sine omega t minus 5. If you differentiate once, it will be cos omega t minus 5, right? Cos omega t minus 5 times you have to differentiate this part, what is inside this these brackets, right? So if you differentiate that, you will be getting omega, right? Okay, fine. So now you can very clearly see that there are certain things that you can take out, right? What are those things? You can basically take this p divided by m omega n squared, right? You can take out, right? Because it is common. Not only that, even this neta also you can take out, right? And what is would be remaining there? Let's put a bracket. So you will be getting k sine omega t minus 5, k sine omega t minus 5, then you will be getting plus c omega, right, cos omega t minus 5, right? So you will be getting these guys, right? Okay, so now what you have to do? So now here you have to obtain some sort of a trigonometric identity, right? So let's see how to obtain that, right? Now what you can basically do is now you know there is a formula, right? Let's just recall that. We have sine alpha plus beta, right, which is a very famous formula. You know what is that formula? It is sine alpha cos beta plus cos alpha sine beta, right? So now here you are going to obtain some relation like that, okay? So that will be easy. So then how can we obtain such a relation, right? Okay, so now what we are going to do is just focus this part, okay? Just focus this part, right? And also focus this part, right? So now what we are going to do is we will be doing something like this. Divide this k and this c omega by square root of, okay, k squared plus c omega whole thing squared, right? So if you do such a thing, you have to introduce the same thing to the numerator over here, right? So let's do that. So what we are going to do is p neta divided by m omega n whole thing squared, square root of k squared plus c omega whole thing squared, c omega whole thing squared, okay? Then here k divided by square root k squared plus c omega whole thing squared sine omega t minus 5, then plus this segment, right, c omega divided by square root k squared plus c omega whole thing squared times cos omega t minus 5, right? Okay, so now we can consider this guy k divided by square root of k squared plus c omega whole thing squared. This guy as, let's say, it has cos alpha, right? And let's consider this guy as sin alpha, right? Okay, so is it okay now? So now you can that means basically cos alpha equals k divided by square root of k squared plus c omega whole thing squared, while sin alpha is considered as c omega divided by square root of k squared plus c omega whole thing squared, right? So that means tan alpha equals, right, c omega divided by k, right? So that is how you define tan alpha, right? Okay. You can further simplify this if you want, right? So how can we simplify that? Because you know that omega n squared, right, equals k divided by m, right? So then what is k? Omega n squared m, right? And what is this c and what is this omega? So now there you can obtain some relationship, right? So let's consider c times omega you can keep. This is omega n squared, k is omega n squared times m, right? Okay. So now there, you know, we have something called c divided by m. That part we can extract. That is an extra part, but I will teach you. C divided by m, okay. Then we have omega n upstairs, then omega n squared. So what is c divided by m? C divided by m is actually, you know, 2 beta omega n. What is c divided by m? 2 beta omega n. Then we have omega divided by omega n, this part, right? So as omega n does not equal to 0, this omega n and this one you can cancel, right? So here you have 2 beta omega divided by omega n, right? So what is omega divided by omega n? That is r, the frequency ratio. So that equals 2 beta r, right? So that relationship is now obtained, right? Easy part, because generally we say tan alpha equals 2 beta r. That means alpha equals tan inverse 2 beta r, right? It's a very simple relationship, right? I just explaining that. It's not necessary here, right? Just for your knowledge, right? So now equals what do you have here? P neta square root k squared plus c omega whole thing squared divided by m omega n whole thing squared, right? So here you can replace, right, sin omega t minus 5 plus alpha, right? You got it? Right. So what is the next part? So you can remove the brackets, of course, right? You don't need to keep with double brackets. You can simply keep it as this times sin omega t minus 5 plus alpha, right? So you don't have to worry about that. And this side we have ft, okay? This side we have ft. You don't have to worry, right? But here just focus this p. What is this p actually there? See, this p is the magnitude of the excitation force, the modulus, right? because when considering the modulus you don't have to worry about the sign part, right? So p is the modulus, so this p you can shift to the other side, so this p will come to the denominator, right? If you shift this p to the other side, that means it will go to the denominator. So this side you will be having ft divided by p. Okay, so this side you have neta times k squared plus c omega whole thing squared divided by m omega n, m times omega n whole thing squared. This guy is okay, sine omega t minus phi plus alpha, right? So that is okay. Okay, right. So now we have obtained up to here, right? So then we are going to continue the calculation from here. So now let's see. We have obtained this, right? So now we know that ft divided by p equals neta times square root k squared plus c omega whole thing squared divided by, right, this part we can write as inside the square root m omega n squared, this whole thing to the power squared, right? So we can write like that. Okay, it's a trick. So then sine omega t minus phi plus alpha, so that sine part will be there. So now you know this part and this part, right? We can introduce inside one whole square root symbol, right? So it is something like neta times, we can put the square root k squared plus c omega whole thing squared divided by m omega n squared whole thing squared, right, times sine omega t minus phi plus alpha. Okay, right. So now how to simplify that? Let's see that. So now we know that neta times square root, we can separate this, right? K squared divided by m squared omega n to the power 4, right? Plus c omega whole thing squared divided by m squared omega n to the power 4, right? So then we know that omega n equals root k by m, we know that, right? So then what is omega n squared? It is k divided by m. So then what is omega n to the power 4? That is k squared divided by m squared, right? So here we have k squared divided by m squared, right? So that means k squared divided by m squared means omega n to the power 4, right? This part is coming here, right? No change. Sine omega t minus phi plus alpha, right? So neta times inside the square root symbol k squared divided by m squared, that is same as omega n to the power 4, right? Divided by omega n to the power 4, right? Okay. And what is next? Plus now. So now carefully focus, right? C squared omega squared, okay? C squared omega squared, in the denominator m squared. Now this omega n to the power 4 we will write like omega n squared times omega n squared, okay? This side term will be there, no change. Let me erase this, right? The thing is every time I have to write that, doesn't matter I will write because we have to learn sine omega t minus phi plus alpha, right? Equal symbol neta times, let's put this square root symbol. Again this angle comes sine omega t minus phi plus alpha, right? So now this is 1, right? You can put 1 here, right? It is 1. Then plus, right? Now omega squared divided by omega n squared. Just focus this part. Omega squared divided by omega n squared. Because we know that frequency ratio R equals omega divided by omega n, right? So then omega squared divided by omega n squared, that means it is R squared. Okay? So now you can write it like c squared will be there, m squared will be there, omega n squared will be there. So this part you can write like R squared. Okay? Right. So now what is next? Now focus this part, right? Okay, so I will move to the other side, right? So now we have reached up to the last line actually, right? So then I will just put some separation, right? Again we have this ft divided by p, right, equals ft divided by p equals neta times square root 1 plus, and we also know that c divided by m equals 2 beta omega n, right? So that means c squared divided by m squared means 2 squared beta squared omega n squared, right? Anyhow 2 squared means 4, that means 4 beta squared omega n squared, right? So then c squared divided by m squared means that is 4 beta squared omega n squared. This r squared term will be there, and here in the denominator we have omega n squared, right? Here this omega n squared. So now we can cancel this omega n squared to this omega n squared. Again we have this sine component there, sine omega t minus phi plus alpha, right? So then we have ft divided by p, right, equals neta times square root symbol 1 plus 4 beta squared r squared sine omega t minus phi plus alpha, right? So now you know what is neta. What is neta? Neta, you already know that neta is actually 1 divided by square root 1 minus r squared whole thing squared plus 4 beta squared r squared. You know that. So now that you can replace, right? Square root this part 1 plus 4 beta squared r squared divided by 1 minus r squared whole thing squared plus 4 beta squared r squared, right? And this sine component, sine omega t minus phi plus alpha, right? ft divided by p. So now here you can see, right, you have seen that this sine component over there, this sine omega t minus phi plus alpha, this part, right, in all these steps, right, I think you could have observed that I continuously used to repeat this part in every line, right? Because if I just neglected this part at the very first attempt, right, sometimes you might get confused, right? So now just focus this sine component over there, and what is there on the left hand side? See, ft divided by p. What is ft? ft is the force that is transmitted to the ground through isolation, right? What is p? that is the magnitude of the excitation force, right? So this is the ratio, right? This is the ratio of the force that is transmitted to the ground and the magnitude of the excitation force, right? So if you are going to consider a ratio, definitely you do not have to worry about the sign component, right? So it's a ratio, so it's a constant, right? So constant means, right, you can't say it's a constant because you can change these values as according to your requirement, right? So if it is a ratio, you do not have to worry about this sign component, right, or that sign part. So you can simply obtain the formula as Ft divided by P equals, here also you have square root, here also you have square root, so you could have written like square root total 1 plus 4 beta squared r squared, right, 1 plus 4 beta squared r squared divided by 1 minus r squared whole thing squared plus 4 beta squared r squared, right? So this is the answer. So now in the next part, part B, it is asked to calculate the maximum stiffness of an undamped isolator, right? So now there is an isolator, right, some isolation system, but it is undamped, right? So we have to calculate the maximum stiffness by using the formula that we have obtained in the previous part, right? So now you know that transmissibility ratio T, that equals, right, square root, okay, 1 plus 4 beta squared r squared divided by 1 minus r squared total squared plus 4 beta squared r squared, right? So now this is undamped. So now undamped means this beta equals 0, right? What is beta? Beta is the damping ratio, right? So then we can sketch the system like this, right? So this is the ground, right? So this mass is isolated from the ground by using the isolation system, right? Or by using the isolation, right? So here we only have a spring, right? Because it is undamped, no damper. Excitation force is there, P sin omega t, right? It doesn't matter, right? So now we can directly use this formula, right? So now what is the transmissibility ratio T? That is the force that is transmitted to the ground, Ft, right, divided by the magnitude of the excitation force, right? Magnitude or the modulus, right? So repeating force, okay, so what is the repeating force? Repeating force is the magnitude of the excitation force, so we know that, right? So what is Ft? Calculate the maximum stiffness, right? Okay, so now here in this problem it is clearly said that the force transmitted to the foundation is 2400 Newton, right? So because now in the problem it is said that Ft is limited, so that means that value is given. So what is Ft? Ft is 2400 Newton, that is given. P also given, what is that? 15 kilonewtons, right? So no problem. So now let's use this formula. Transmissibility ratio is Ft divided by P, that means 2400 divided by 15 kilonewton means 15,000, right, equals square root 1 plus 4 beta squared r squared. You don't have to worry about that, right, because beta is 0, so here you have only 1, divided by 1 minus r squared whole thing squared plus 4 beta squared r squared, and here also you don't have to worry about beta because it is 0, so what you have is 1 minus r squared total squared, right? So now we have obtained up to here, right? So now the better way to solve this is by squaring both the sides, right? squaring both sides, right? Okay, so before squaring both the sides, right, it is better to simplify this side. Okay, so that means 2400 divided by 15,000, that means it is 24 divided by 150, right? Then 3 times 8, 3 times 50, right? 2 times 4 and 2 times 25. Okay, right? So that means on this side, which is the left hand side, we have 4 divided by 25, right, equals square root 1 minus r squared whole squared, right? So now we have to square both the sides. So that means what will be the answer? If you square this side, you have 4 divided by 25 whole squared equals, and if you square this side, this square root symbol will eliminate, right? So you have 1 minus r squared whole squared, right? So now we can do cross multiplication. So then it will give you 1 minus r squared whole squared equals 25 divided by 4 whole squared, right? So then now you know, now if you take the square root of both the sides, right, then you know that 1 minus r squared equals, right, plus or minus square root of 25 divided by 4 whole squared, right? So now we have two possibilities, right? That means we have two approaches to obtain the answer. So let's focus the approach number 1 here, right? So what is the approach number 1? It will give you 1 minus r squared equals positive square root of 25 by 4. So what will be that answer? So that will be 25 divided by 4, right? That is one option. Now what is the other option? Other option will give you 1 minus r squared equals minus 25 divided by 4, right? So if you follow this option, you will be getting, if you put r squared to the other side, r squared equals 1 minus 25 divided by 4. So that means, right, so here you will be getting, putting 4 there, 4 minus 25 is minus 21, right? So minus 21 divided by 4. That means from this path you are getting r squared equals minus 21 divided by 4. So this path is not acceptable, right? Because when you square the frequency ratio, you are getting a negative value. So this path is not acceptable, right? So then let's follow the other path, right? So then from here you are getting r squared, if you put to the other side, 1 plus 25 divided by 4. That means you are getting r squared equals 29 by 24. But this path is acceptable, right? Because if you square the frequency ratio, you are getting a positive value, right? So that would be better, right? So then what is r squared then? Then r squared we are going to consider as 29 divided by 4. That means r equals square root of 29 divided by 4. That answer will be the square root of 29 divided by 4 will be 2.6925. 2.6925. So that means better consider this as 2.7, right? So 2.7 is the frequency ratio, right? So then from here we can again continue, right? So then I will erase this part, right? Because I need some space. Okay. So now we know that r equals, right, 2.7, and also we know that r is the frequency ratio, which is omega divided by omega n, right? So now in this B part they are asking calculate the maximum stiffness, right? Okay, And also you know that omega n equals root k by m, right, where m is the mass, right, of the system, right. So then omega n squared equals k divided by m, okay, right. So then what is k? So then k equals omega n squared times m, okay, right. So now again look at here, right, we know r equals omega divided by omega n, right. So from here we know r equals omega divided by omega n, right. So then what is omega n? Omega n you can subtract from here. So what is omega n actually? Omega n is omega divided by 2.7, right. So what is omega? So in this problem they have given omega. See, machine of mass 1000 kilogram and operating at a speed of 1500 revolutions per minute, right. That means we know rpm, right. So then if you know rpm, so rpm is given as 1500 revolutions per minute. So that means 1500, that is given in revolutions per minute, right. So what you have to do is, if you want to get the angular velocity, 1500 multiplied by 25, right, divided by 60, right, and this answer again you have to divide by 2.7, right. So now you know what is omega n, right, and the fact is that you have to square that, okay. So that means 1500, focus here, multiplied by 25 divided by 60 multiplied by 2.7, right. This whole part you have to square, multiplied by the mass of the system. So what is the mass of the system? 1000 kilograms, 1000, right. So let's see what is the answer that we are getting, right. 1500 multiplied by 25, okay, divided by 60 divided by 2.7, right. You have to get the total square of that. Total square of that, then multiplied by 1000, right. So the answer will be, it's a very larger answer over there, right. So 338 4637 4637.99. So that means it is 3,384,637, right. So it's a very large value. So what will be the units? Stiffness means it will be newtons per meter, right. Nm minus 1. So this is Newton, right. So now it's a very large value, right. So now what you can basically do is, you can convert this into kilonewtons per meter, right. So kilonewtons per meter means you can divide this by 1000, right. So then the answer will be 3384.637. It doesn't matter, you can consider 3384.6 kilonewtons per meter. So let me check the answer. 3384.6 kilonewtons per meter, right. Or else you can keep the final answer as 3385 kilonewtons per meter, right. So that is also acceptable, right. So now this is the maximum stiffness, right. So I hope you got this part. Okay, so now let's consider the C part, right, part C. So there they are asking if the damping ratio of the isolator is 0.25, that means now the damping ratio is given, that is beta equals 0.25, right? What would be the maximum stiffness, right? So in this part also, that is same as the previous part, right? The only difference is that now we are given beta, right? So how to solve this problem? So now you know we can use the same formula, right? Where transmissibility ratio T equals 1 plus 4 beta squared r squared divided by 1 minus r squared whole thing squared plus 4 beta squared r squared, right? So now the forces are same, right? Now what is transmissibility ratio? That is the ratio of the force that is transmitted to the ground and divided by the magnitude of the excitation force, which is P, right? So now you know what is Ft, right? So Ft has not changed, right? So that is 2400. Magnitude of the excitation force is what is that? 15 kilonewtons. That means 15,000, right? So that equals, okay. So now here you have to be very careful. So let's write it as like this, right? 1 plus 4 beta squared r squared divided by 1 minus r squared whole squared plus 4 beta squared r squared, right? So now this part you can simplify, right? You can cancel double zero, you can cancel, right? So here it is, you know that 6 into 4 and here 6 into 25, right? So that is also okay, right? So then we have 4 divided by 25, right? Square root 1 plus 4 beta squared r squared divided by 1 minus r squared whole thing squared plus 4 beta squared r squared, right? So now after this point, right? So now what is the way of solving this type of a problem? In the previous part also I have told you that the better way to solve this is by squaring both the sides, right? So you have to square this side and as well as this side. What is the reason? Because if you do the squaring of both the sides, you can eliminate the this square root part, right? So squaring both sides will give you 4 divided by 25 whole thing squared equals 1 plus 4 beta squared r squared divided by 1 minus r squared whole thing squared plus 4 beta squared r squared, right? Okay, so now be careful, right? So now this beta is given, right? So you, right? So what is beta? Beta is 0.25, right? So now you can put the values. So here it is 4 divided by 25 whole thing squared. Okay, so right, so now be careful, right? 4 times beta squared times r squared, right? R squared you can keep like that because r you don't know, right? Because r you have to find by using this formula, right? 4 times beta squared, beta is 0.25. So if you carefully do calculations, you will be getting that 1 plus 4 into 0.25 squared will be 0.25, right? If you carefully do the simplification, so it will be 0.25 r squared, right? Divided by 1 minus r squared whole thing squared plus 4 into 0.25 squared into r squared. So that is also 0.25 r squared. Okay. So now we have obtained up to here. Okay, right. So now, okay, let's move to the other side, right? Right. So now 4 divided by 25 whole thing squared. So what will be that? So 4 divided by 25 whole thing squared will be 0.0256. 0.0256, right? Right. Equals this side 1 plus 0.25 r squared divided by 1 minus r squared whole t squared plus 0.25 r squared, right? Okay, so now we'll do some substitution, right? We'll follow some trick, okay? Right, don't get confused, we are just using a trick. What is r? R is actually the frequency ratio, omega divided by omega n, right? So here we will substitute, right? So here we will say that r squared is s, right? Another variable, right? Because otherwise if you use this formula, if you use these terms, right, so you will be getting a fourth order equation, right? So we'll just say that r squared is s, okay? It's not a big thing, right? Let's say r squared is s. So this side 0.0256 equals 1 plus 0.25 s, okay? Because I have told you that consider r squared as s, divided by 1 minus r squared means 1 minus s squared, right, plus 0.25 s, okay? Right. If you carefully do simplifications here, you will be getting a quadratic equation of this format, right? So I will write it here, right? So if it is wrong, you can comment me. If there is any mistake, you can comment. After carefully, if you do your simplifications, you will be getting a quadratic equation like s squared minus 737 divided by 64 times s squared minus 737 divided by 64 times s minus 609 divided by 16 equals 0, right? Okay. So if you solve this, right, mostly you can use your scientific calculator, right? So now if you solve this equation, definitely you will be getting two answers, right? So you will be getting s equals 14.19670 minus 2.6810 1967, right? So now here you know, right, that r is the frequency ratio, which is omega divided by omega n, right? So it's the ratio. So if you square this ratio, right, so if you do squaring for r, then you will be getting r squared, right? So that means definitely that r square must be a positive value, right? So it cannot be a negative one, right? The simple logic there, right? And also you know that we have considered that r squared as s, right? So definitely from these two answers we can consider only one answer, because definitely we have to neglect this one because it cannot be, right? So this is the only possible answer, s equals 14.1967, right? So that means now you know, right? So now you know as s equals r squared. So now you know r squared equals 14.1967, right? So if you take the square root of this, if you take the square root of 14.1967, then the answer that you are obtaining is 3.77, right? 3.77, right? But actually the answer that is coming here is not 3.77, it is actually, let me write that, it is 3.7678, but you can round it up to 2 decimals, so then it is 3.77, right? So now you know the frequency ratio, right, which is r, right? So then after that it is very easy, right? So let me erase this part, right, because I need some space, right. So now what is the next thing? Okay, so now here also we have to find the maximum stiffness, right. Okay, so now we know the R value, right. We know that R equals omega divided by omega n, right, because omega is actually given, right. So what is omega? From part B, we know that machine mass operating at speed of 1500 revolutions per minute, right. So you know that omega, right. So R also you know, right. So then this implies that what is omega n? So our omega n will be omega divided by R, right. So that you know. The next thing, you know that omega n squared equals k divided by m. And now here we have to find k. So then what is k? K equals omega n squared times m, right. So what is omega n squared? Omega n squared will be, now there we can substitute this relationship, omega divided by r whole thing squared times m, right. So now we have to be very careful. We have to substitute all the values in standard units, right. So what is omega? 1500 rpm, so that means 1500 multiplied by 2 pi divided by 60, right. And this value we have to divide by r. So what is r? 3.77, right, and we have to square that, right. What is machine mass? 1000 kilograms, right. So if you simplify that, so what will be the answer? 1500 multiplied by 2 pi divided by 60 divided by 3.77, and we have to square that whole answer and multiplied by 1000. So you are getting an answer like right, 1,736,029, 1,736 and 29.31, right. So you are getting a very large value in standard units. So that means in newtons per meter, right. As it is a large value, right, you can divide this by 1000 and you can keep the units in kilonewtons per meter. So if you divide this by 1000, you will be getting the answer in kilonewtons per meter. So divide this by 1000 means take 3 decimals backwards, 1, 2, 3, 1736.029, right. So doesn't matter, we can consider it as 1736, right. So what are the units? Kilonewtons per meter, right. So that is the answer, right. So that is how you should obtain the answer.